Ladies and gentlemen, welcome to video lecture number 10 in a series of video lectures that are companions to the book, The Fivefold Sun. The Fivefold Sun as a paper version was filed at the Bibliothèque Nationale de France in Paris in late 2017. We are today, November the 13th of the year 2018, about a year later. We today will deal with the part 2 of the book, The Fivefold Sun, namely its section 6 of part 2, which deals with observational evidence of icosahedral symmetry in the Sun's interior. First part of the investigation of such evidence, the solar core's radius. The second part of this investigation will deal with a larger region of the inside of the solar ball, which is predicted in case of an icosahedral symmetry at a radius of 0.655 radius fraction of the solar photospheric radius. You see in the contents of part 2, which is quite a long part divided in several volumes in the text version, we are in part 2b, observational evidence of icosahedral symmetry in the solar ball's interior from the Sun's radius fractions. And we are in section 6, which is, as said, evidence of the predicted icosahedral central cavity, which is predicted by icosahedral symmetry to be located at 0.31 radius fraction of the solar photospheric radius. Contents of video 10 start with step 1, how far are we in the Fivefold Sun? This video number 10 deals with the fifth of 15 text volumes which in all compose this 6,000-page book, The Fivefold Sun, as filed in 2017, last year, at the Bibliothèque Nationale de France. And video 10 is the end of the first 3 hours of video lecture companions to this book. In all, we'll have more than 10 hours of such lectures. I show now the volumes which we dealt with so far. That is the first volume that was discussed in video 1. In part 1, it's volume 1. Then we dealt in video 2, video 3 with part 1's volume 2. And then in the next few videos in this big part 1's volume 3. Then we moved to the second part 2, and we dealt with volume 1 in the next few videos. And we are now in volume 2 of part 2. We can now shortly recap what was said in video 8 and video 9. We defined a number of measurements to serve as criteria to be checked against the actual Sun. We found in video 9 that there are 6 remarkable angles in the regular icosahedron, which we will have to find or not find in the actual solar ball. And we found earlier in video 8 that there are 2 remarkable radial fractions in the suggested icosahedral 12-ball arrangement for the Sun. And these are the 2 remarkable fractions for a central cavity or core located at the heart of the 12 outer balls. We have a 0.3108, etc. radius fraction of the overall larger sphere. and more outward shell boundary, which is expected to be located at 0.655. This is not discussed today and will be dealt with in video 11. So we are now dealing with this fraction in video 10. We will now have a look at this suggested arrangement as it was already shown in video 8 for the 3D version. So this is what was shown in video 8. We have an arrangement of 12 balls that are hard balls with equal radius, equal diameter. Here is a polar, north polar ball in as much as it is located, its center is aligned with a vertical axis, which we can interpret, for instance, as a rotation axis. And if we remove this ball, we see that inside this arrangement we have a cavity. This was shown in video 8. The hole in the bottom ball, which is now at the rear, is where the axis that was mentioned in the previous sentence passes. It is like a rotation axis. This ball is like a southern polar ball, now in the rear. And you see that there is a cavity in the center. And the diameter of the cavity we saw in video 8 is found to be 0.3108 radius fractions. Radius fraction of the radius of this outer sphere. So in the case of the Sun, this would be as much of the photospheric radius. Now, what is in actuality the size of the central spherical region of the Sun, which is known in solar physics as its core? If I look at a sphere like this and say this is a solar-like spheroid, and if I look inside this sphere, I can imagine various radii for an internal core. You see, I have here a set of various sizes for such cores. In this case, we have the large case. This is a smaller core. This is a still smaller core. And this is the smallest case to be shown here today. In fact, between the large case and the smallest case, we have only a ratio of 2 in the second largest and the smallest case. There is only a ratio of 2 in the radii. But you see, visually, it is quite impressive to see how the configurations differ with only a factor 2. So we will now look at some observational evidence with, as our guiding principle, falsifiability, which is at the root of the present test and is a notion that was introduced by the philosopher of science Karl Popper. For instance, in his 1959 book, The Logic of Scientific Discovery. The principle is that if there is a purportedly scientific theory, it must be falsifiable. I.e., it must be possible to refute the theory. So now if we find in the Sun that something is not consistent with fivefold symmetry, especially not consistent with the suggested arrangements which was just shown, then we will conclude that this theory is not representative of reality. Later in this discussion, we will use, especially for angles in the solar phenomenology, this 2D projection of what was shown before in 3D, in which you see the two polar balls are obviously in the same plane, but also this ball and this ball are in the same plane as the polar balls, where the two other ones are just projected in the 2D plane. So you see in this 2D projection, we have in the center of the drawing a dotted circle which represents the theoretical boundary of a core having a radius of 0.31, etc., radius fraction versus the large sphere's radius. This is what we are going to check in the following. This is just a 2D representation of what was shown in 3D in the glass ball before. Why do we start with the most inward radial fraction of the solar interior when we want to test the falsifiability of our fivefold theory? The concern with such a choice is that the innermost region is, as is well accepted, the least known region in the Sun. It is a region for which there is the least diverse set of measurements. They are the most uncertain, and there are very few such measurements. In the Fivefold Sun project as a book, there is only less than 50 pages out of about 6,000 that deal with this region. Yet we start with this test now because we want to start in this sequence of video lectures from the innermost region of the Sun and then go rigorously outward towards the solar surface. And mostly because we want to use this innermost region as a KO criterion, an acid test, so to say, to start with, because it's a very simple yardstick. If there is not a core having a radius of about 0.31 radius fractions of the photospheric solar radius at the core of the Sun, then the Sun's constitution cannot be icosahedral. And in this event, we do not have to go further, and we save a lot of time. We now, in step 6, go back to a definition of what we have to investigate, which is the Sun's core region. It is defined in solar physics literature quite widely as the energy generation zone, which is about the Sun's center. The accepted notions is that this zone is a spherical shell or a spherical ball around the Sun's center, centered at the Sun's centers, and that it is the nuclear fusion zone in the Sun. So how can we define its outward boundary? That is where the full solar luminosity is reached by these fusion energy reaction cycles, and it is also the radius at which there is no more any evidence of any fusion reaction cycles going on. How is this boundary detected? A, so to say, direct detection, or the least indirect detection, is by neutrino fluxes. This is a recent possibility, so there are, as of present, still not so many measurements. And the other ways of detecting the boundary are even more indirect, through changes in sound speed, through changes in angular velocity, and through changes in energy density. So we now show the result of a meta-analysis of the published observational measurements of the radius of the Sun's core, and we find that it is close to 0.31 radius fractions of the photospheric solar radius, plus or minus 0.005. While this might be a little too precise, this is what is stated in the book paper version and electronic version of the Fivefold Sun as a book. Maybe it is more prudent to say that in the literature the meta-analysis leads to conclude that the radius of this core is more than 0.30 and less than 0.32. In section 6.1.1 of the book is performed a meta-analysis of the data inferred in the extant publications from detected neutrino fluxes, in which the result 0.315 radius fraction is asserted in this project. This, however, is based only on 5 sources and is a result that obviously needs to be confirmed in the future. In 6.1.2, a determination was performed not from meta-analysis but from the raw data that 2 authors were so kind to provide me. And I found 0.315 again. But it is important to note that these sound speed measurements or inferences lead to and are based on models that are mutually relatively inconsistent. The same is true for determinations of the boundary of the solar core from angular velocity data in section 6.1.3 of the book, where we see that most authors preset the boundary of this zone at 0.30 radius fractions, but this is not based on observations. In 6.1.4 is found from just one publication that based on energy density data, the core boundary seems to be located at 0.309 radius fraction. Again, this is based on just one publication, and this estimate that is now stated in the previous sentence is my estimate and is only implicit in the data of this author. So we can say as a conclusion that the result of the meta-analysis show that radius of 0.31 as predicted in the case of icosahedral symmetry is not excluded by the data. It is not falsified by the data. On the other hand, the data do not suffice to prove that the radius of the energy generating core is exactly in the range of 0.31 or 0.3108 as predicted by icosahedral symmetry. But this KO criterion is positive for the hypothesis formulated in the Fivefold project in this respect, and we can proceed with further investigations. In video 11, we will deal with the next largest shell in the interior of the Sun, as predicted by fivefold icosahedral symmetry. I thank you for your attention.